So this is our basic metal detector circuit. We have 5 of these in an array for the full circuit that you saw earlier. And so here you can see you bring in metal and it flips the LED. That's what our circuit does.
Here's the diagram for our circuit. We start with a physical input to the Hall sensor, to the voltage control, to a comparator. Then depending on the voltage, either the metal present LED or the metal absent LED. Because of the bias magnet, there is a constant voltage produced by the Hall sensor, north pole positive. We use the pot to calibrate the reference voltage to be just above the value. So the non-inverting input is higher and the comparator rails to 6 volts, making it so that no current can flow through the upper LED. Then when the metal is brought in front of the sensor, the field changes and increases the voltage out of the Hall sensor. The comparator sees the higher voltage on the inverting input, so it rails to 0 volts. This switches the current through the upper LED. The metal present LED then lights. Notice also that we have an additional diode between R2 and LED2. This is used to drain the bleed through voltage that we originally were receiving.
And so that's the single circuit that we built. And so the next thing we had to do was we built an array of 5 to get a larger detection and position area to test. And so here's our final array, the final circuit that we're going to build. But before we show you that, we have a couple things we learned along the way. For myself, I learned about potentiometers. I actually tried just sticking in a resistor in the original circuit and burnt out our first Hall effect sensor because I didn't know what the symbol for a potentiometer was. So I learned what the symbol was and then also how to use one and what changing that does. Also comparators. I didn't quite understand what was going on there, but after sitting down and looking at this circuit, I saw how it rails to the power and the ground voltage and how that changes the circuit it's connected to. And James, what did you learn?
Well, there's a couple of things we learned from the beginning. One, this one is an on and off Hall sensor, and this one is the variable Hall sensor. Took us about an hour to figure that one out. Also, though it's hard to see, this is the front and this is the back. And that took us about 2 hours to figure out. But one of the biggest things I got to stress about this is your diagnostic skills. We came in here without a plan, built the circuit, didn't get it done, and then we had to step back and essentially come up with a development protocol, basically steps on how to do things. So it basically breaks down to 25% build, 25% design, and 50% test. If you're really good, you get it 15, 15, and 70. So that's one of the most important things we did learn.
So yeah, that's our metal detecting array. You can see that each LED corresponds to the Hall sensor in the same position, and eventually we would hope to be able to use this to find where a piece of metal is. All right.